appreciate you coming out on a Monday night, and I think it's a pretty nice opportunity to hear from an actual craftsman and his assistant about a pretty awesome project. Just to give you a little background, really meeting Dávid was a serendipitous event. It was in 2009 at the Najga, it was Proto-Najga conference in Long Beach, and kind of at the end of a viewing of the Japanese American Community Cultural Center in Los Angeles. There had just been a renovation of that garden with some bridges, three bridges there, and I saw Dávid there. I think he had just finished working on those bridges.
That's what I told him.
Yeah. And so we exchanged cards, and then I think you were traveling in 2010 back from doing a timber frame house in New Hampshire, in Maine. And he just dropped a line saying, I'm headed back, I'd like to see the garden. And that happened, and we were looking at some of the problem bits of architecture out in the garden. We had issues with both the machiai and the gazebo at that point. They were really falling over. The bases of the posts had rotted out. Those posts had been just sunk in concrete in their original construction and were rotted out at the base. And we're in pretty bad shape, actually. And so we looked at those projects, and when I heard Dávid's logic behind his approach to those things, I thought, this guy can do it. And I was like super happy and excited at the possibility. And then we worked things out, and in 2011 Dávid came back and worked on the complete dismantling and restoration of the machiai. And it's still, and now we think it's going to last a long time. The posts are sitting on rocks that have threaded rot going through them into the posts, down into proper foundation. And so that was a success. It went really well. In 2013, we took the gazebo down, completely dismantled the gazebo, and then into the fall, and then in the next spring, the garden guys, pounded out as much of the concrete from those original post bases as we could. We poured concrete. Maybe you were here when we poured the concrete.
Oh,
yeah. And then in 2014, over the course of about 6 weeks, I think, we completely put the gazebo back together. And again, the round gazebo at the waterfall. And again, that the objective is to do these things so that they last a much longer time than they did the first time around. And then subsequently, we did some tea house restoration on the backside posts in 2019. And then Southgate in 2022. One or two. Again, a complete dismantling, proper foundation underneath it. Posts are now scribed and sitting on rocks, and so it's turning into a nice long history of projects that we've done, and respectful restorations, I would call them, of historical garden structures. And then of course the Giboshi Bridge we've been working on for a long time. But maybe I'll leave that, Dávid, for you to discuss and explain. So it's really great to have Dávid back, and for the first time his assistant Danny Shimoda is with him, and they're just a great team to work with. And have you all seen the bridge out there and the work that's been happening? It's pretty fantastic, and so really thrilled to have this project almost behind us, and looking forward to more. So please welcome Dávid and Danny.
And just as a forethought, I really appreciate everybody's presence here and your dedicated service to the garden, and showing up and showing around to other people around here. As some of your members that I have seen for the past 14 Rockford and people who are coming from far, far, far away. Thank you.
Can you speak a little bit louder?
I will try.
Okay.
So, I think it would make a lot of sense to go through the whole process of what we did with this project when 13 years ago John Anderson approached us and said, I really don't like that bridge, what can we do about it? So we looked at several design possibilities, and we found in the archives a couple of renderings. This was actually at the bottom of it, there is an HK, Hoichi Kurisu's signature at the bottom of this one. I don't know why it doesn't show up. But this is this was an original design at one point with the 5 posts. I don't know what the decision was when in 2002 the bridge was actually made with 3 posts. Obviously those were done by local carpenters here. In our case, I voted for this one for 2 reasons. One of them was that if you only use 3 posts, then the span in between the posts is almost 24 feet long. And in order for us to be able to work with those timbers, the timber cost would be higher, obviously buying longer pieces. My shop restriction would have limited itself completely out because we only have 53 feet, and I need 8 feet at least for the machinery in the middle, so we wouldn't have been able to mill it. And the third reason was to ship all this timber out from California to here to Rockford. That would have occupied basically half a semi-trailer. And with the shipping cost in mind, I was really pushing and hoping that this would be the design. Eventually, we settled down on this design almost to the dimensions that are actually present on the next slideshow, or on the next slide. We scaled everything down. These were made by someone in Japan, I believe, and so everything is in millimeters. But we translated all those into the American system, and we were able to figure out what the sizes we were talking about and what we needed for the project. This is actually a rendering of the original height of the posts that were here. So we were trying to figure out, does it make sense to bring up the handrail a little bit higher? Is it dangerous? Is it comfortable to lean on it? What would make more sense? And then this is the final design that we came down with. Please don't measure the distances on the bridge because it may vary. But that's just the nature of the material, how we work with it, and how we came to the final distances between the bottom rail, the mid rail, and the top rail. The posts, and the next please. So in order to make the post and all the bridge parts, we ordered the materials. There was fundraising going on after the decision was made that the bridge will be replaced, the railing will be replaced. We knew that the decking will be replaced at one point. We sourced some really nice 4x6 epay, which is going to last more than one lifetime, I really hope. And then we sourced the material back in 2018 from British Columbia. The material is Alaskan yellow cedar. To make it a little bit more confusing, it's actually a cypress, but they call it Alaskan yellow cedar, and it's one of the best material to obtain these days. For several reasons, it stands up to fungus, which is basically what dry rot is. It's a fungus, and very good material to keep outside. It will not rot, and termites will not get into it. So those reasons definitely pushed for the material choice. Once we ordered the material and we got them, I think 4 or 5 months later, we didn't touch them for the next 3 years. we actually did one thing with each timber. We cut a curve right into the middle of each 6x6 beam. And that curve is what the Japanese call is a sawari, which basically allows the timber to dry out from that side and change its shape from that side where the curve is, and no other three sides will crack. So once it went through an air drying process of 2.5, 3 years outside, we brought it in inside and then stored it inside. The moisture content went down to the point where it was suitable to build furniture out of, which is very rare in our case to build something out of that dry material. This was the first step that we did, that we actually milled all the material. Milling means you put it on a joiner and a planer, and then you make it so it's rectangular piece, but the sides are parallel to each other and square to each other. And then little grooves were cut into each of them at certain spaces, so that when we put them together into forms of four, next please, these actually created later on the posts. So we carefully selected the grain orientation, so nothing really flat sun area would show. We really wanted to make sure that the quarter sun area would show up. And they would need to go out to the garden, but if you look at some of these posts, there's only one post on one side that shows flat sun, really nice grain direction. Everything else is basically quarter sun. Quarter sun means that the growth rings are perpendicular to the surface of the material. So this was just figuring out what needed to be glued up in order to make up the posts. All were marked with different symbols in order for us to be able to identify them. And eventually, next please. Eventually, we used these little dowels here that went into those grooves. It helped us to stabilize the material and align them. And we used epoxy to glue up these 6 foot long 6x6s that were basically 12-inch by 12-inch timbers. Each of them weighed probably 85 to 90 pounds by the time they were done. Next please. And we carefully cut the corners off so we could put it on. We actually hired somebody to do it, to turn them on a lathe. I don't have a lathe in the shop, I wish I had, but these pieces were just way too big for us to turn them. And luckily in Santa Barbara, very close to us, there was a person who had a large lathe, and I've been talking to him about this for the past, I don't even know, a very long time. And finally, he was able to turn them. You can tell that the moisture content was on all the pieces, note 4.9, 5.5, and the timing when the material arrived at the shop, which says, I think it was April 23rd in 2020. Yes, please.
How do you measure the water content?
The moisture content is measured with the little device that you actually just put on the timber, and it picks up moisture, I believe, 1 inch deep into the piece.
Okay.
It's an industrial standard measurement. The moisture content cannot be 100%. The moisture content, when it's measured with the moisture meter, it maxes out at 33%, I believe.
Thank you.
Sure. And then after that, we had to cut the ends off to make them perpendicular to the sides. And then we actually sealed all the ends so that they will not pick up more moisture. Because in our area, we can have a very wet winter, or we can have very dry summer. So we don't want this material to go through all these cycles. So each time we cut the timber on the end grain, we seal it right away. It's not an oil finish, it's actually a penetrating water-based wax finish that we put on that, but this is not the final finish that you see on the bridge now. Next, please. And so eventually, a couple of months later, this is how they came back. And you can tell that everything looks very, very vertical grain, so there's very small amount of flats on grain shows up. This is actually one of the posts that's close to the gate now that shows a little bit of that grain direction. And it's an unfortunate thing. I wasn't able to project what that grain is going to do in that piece inside by the time it was done. So when these pieces were turned, obviously the bottoms were turned so that they would fit right into the bases that were custom made by Tim and his crew out here. Beautifully handcrafted pieces. The challenging part was that we have a 157-foot radius, I believe, to the top of the I-beams. And these I-beams are massive 14-inch by, 10-inch I-beams. We have 4 of them under the bridge with that 157-foot radius. And so when you place a base on it, you can't place it so it's perpendicular to the decking boards. It has to be in the right angle level at each point. And each point measured differently. So each of those 5, I don't know if they actually made them symmetrical or they were all measured out individually.
So the guys that figured that out, I worked with the guys at Architectural Metals in Wells Park, and they made a gauge that sat on the deck with a pivoting arm that allowed them to level the arm. And I should get some pictures of this that we could add to this presentation.
We'll do that.
And then they were able to calculate the angle for the location of each post. And then they took careful notes, and then took that back to their shop. We knew what the diameter needed to be based on the design of the bridge, and
For the
and so
posts.
then those bases were then fabricated. Dávid and I worked out. Dávid, are you gonna talk about these bases at all, or should I keep
We'll
going?
have a couple of pictures of that, but go ahead.
And so our objective with these bases was, for the first thing, they're made out of stainless steel, so they'll never rust, and they're powder coated, so that finish will last a long time. So powder coating is it's sprayed on and then it's baked in an oven.
Heated.
Yeah, and so basically the posts sit above the deck inside the base, so that the base will not touch the deck. There's an airspace in there, and they sit on an open web of steel, so that the posts can breathe through the bottom.
And then there's a flange all the way around that gets screwed down to the decking and will hold the post down with the base securely to the decking. Next, please. This was one of our first challenge, that we needed to make the post a little bit bigger than what the bases were. And in some cases they ended up a little bit too big. There was no way for us to be able to hand plane, because each of those posts and each member of the bridge was hand planed. So in order for us to be able to hand plane, this was 3/16 of an inch. That would have taken a very long time. So eventually we decided to leave them much prouder than what the bases are. And as it turns out, this is probably the best solution, because as water will hit the post, it will come down to the post base and will repel down onto the decking. So there will not be any water going inside the base and start the rotting process. Previously, before we removed the original or the 2020, or was it 2002?
2002.
2002 bridge railing, I was able to push in my 12-inch ruler into the joint where the mid-rail came to the post and went 8 inches into it. So that's how much dry rot happened in that space. And then came the very time-consuming and very precise way of having the 6x6s. These were 14-foot long 6x6 timbers that we had, and we had a CNC shop manufacturer for us out of MDF, which is medium density fiberboard, a template. This one became the master template for us for the 157-foot radius. Because each piece on that bridge was cut out from a single piece of 6x6. You can tell the lines here that this is how much gets cut at the beginning, and then basically there is nothing that gets cut down here. This is the top of the piece, and then this is the bottom of the piece. So once we drew out each member, we marked them, and then we cut them on the, let's see if this one actually shows, we cut them on the bend saw, and you can tell that the saw cut is very small at the beginning, and then it gets wider and wider as I'm cutting the bottom. In this case, we actually had, so the top rail and the mid rail were all cut out of one 6x6, each of them. And then the bottom rails, we were able to cut two of them. You can tell the red line, this one is one piece, and then this is another piece. We had to be very, very careful when we pushed it through the bend saw, because we knew that we wanted a certain dimension. And we were able to keep it at a very tight tolerance at that point. This is actually, you can try to push that. So after we have the bend saw cut, this is a very rough cut, and so can you go back to the previous one? And just don't play it. This is a very rough cut on the top surface, and it had to be smoothed out down to the line where we actually had the template line marked. And in order for us to be able to do that, we used a small 4 3/4 inch handheld power planer, and went back and forth like you were ironing clothing, and back and forth until we hit a certain point, but we still needed to be just a 32nd or a 16th of an inch higher than the line, because right after this procedure, we took a hand plane, and that would be the next slideshow, or the next slide. We took a hand plane and we carefully removed all the material down to that line. So each member is different. No two members are the same, which is a fun part when it comes down to matching once we figured out what's gonna be the top rail, the mid rail, and the bottom rail, is to try to find and figure out where the posts are going to hit and how tall they need to be and what angle they need to be cut at. So once we managed to do the top, we were able to cut each bottom, and we were able to send it through a planer so we could get two parallel surfaces. It was a very careful production method. I don't know how much time we spent on it, but it was definitely weeks and weeks by the time we get to the point where we have the right thickness, everything is perpendicular to the sides, the top and the bottom are parallel to each other. And that's when this one just shows Danny trying to figure out where he needs to take material off from the left side or the right side. We knew that we needed to be perpendicular to the sides in order for us to be able to scribe pieces in between and come up with the right angle. This one just shows how we planed the top. There needed to be special jigs made in order for us to be able to send it through the machine. Luckily, the curvature wasn't too small, so sometimes if it's too small of a curvature or radius, then by the time you send it through, the material hits the floor. because the machine is not that tall. In our case, the radius was way too small. I mean, what was that? Maybe 1.25 inches difference between the two ends and the middle. So we were able to send it through. And then we, out of that 6x MDF piece, the main template basically, we created half a bridge out of 3 pieces of plywood. What you see there is 3 pieces of 4x8 sheet of plywood with a very nice MDF sheet glued to it. And we drew out half of the bridge from the first post to the second post, and half of the middle post was shown for us. But that gave us the bottom rail and the mid rail, and we used the mid rail as a top rail, and we used the bottom rail as the mid rail when we needed to transfer numbers in between them. So that took a little bit of time to figure it all out, but then we were able to place all these pieces on the actual template, and from the bottom up, so this was one post going up, and we knew that the original design that I showed as a first piece, we had the 1 post, 2 posts, 3 posts, 2 posts, 1 post design. So we already marked all of those posts up, all the way up here, and we were able to transfer the lines straight up onto the timbers. So we knew where the actual post will be without even trying to figure out by using a marker. It's called the French scribing method, but it's a very accurate method. Or pencil lines, which is not really a pencil, it's a ballpoint pen, is 0.3 millimeters. So we were able to really pinpoint every single joint where they needed to be. And we just transferred those lines up into the timber, and then came another time-consuming part where joinery needed to be marked. We had 112 posts, and you need to mark those on top and the bottom. So we had to double that up, and we had to mark both sides of the joinery. So we spent, I think, a good week just marking the joinery where all the posts are going to be. At that point, we knew what the post sizes are going to be, and so it was easy to see. Danny's marking out the center line of each joint, which is one of the basic, when it comes down to Japanese joinery, in order for us to be able to cut precise joints, we measure from the center. So each post had to have the center line marked on it on all 4 sides, top and bottom, and each of these pieces had the center line marked on it, and then we could mark left and right in order for us to be able to cut the joints. It's a fairly standard way of doing it, because the square that you might have seen us using on the job site is 15 millimeter wide. So you just place one edge of it onto the center line, and you mark the other side of it. You flip it over the center line, you mark the other side of it, and you have a 30 millimeter gap. And that's what we have, because we have 30 millimeter mortise bits that we'll be using in order for us to be able to cut the joinery. It became a really interesting part that we needed to store all this timber somewhere while we were working on other parts, and we were just moving the pieces back and forth. I don't know how many times we shoveled them left and right. Each of these would weigh between, I would say, 65, 75 pounds.
Ooh.
So this actually shows the joinery already being cut with a mortising machine. We do use machinery because we need to speed up the process. We could have done it by hand, but we would be doing this presentation next year in the fall. So to speed up the process, we use a mortiser machine that actually clamps onto the timbers, and then you use an arm, and then it drills right in there. This slide shows after the bottom, the mid, and the top rail, all the joinery were cut on it. We used spacers on both ends to keep the right distance, and then we placed them, we always placed them so they would hit the edge of the actual post. And that becomes very important at this point because we ended up making them a 1/4 inch longer than what we thought we would need in order for us to be able to correct anything that may not be 100% on the bridge. And it's very interesting to see the bridge. If you walk over the bridge from this side going south to north, if you look down, the pavement on the left side is right up to the decking. On the right side, it's 1 inch lower. The decking is 1 inch lower than the pavement. And so that the bridge is tilted this way a little bit. And for some reason, we don't know why, we just discovered that too, that there are 4 I-beams under the decking, and the middle 2 is probably a good 3/16 lower than the side ones. So when we place the railing on the 2 edges, they all lean in a little bit. You can barely tell. We were able to fudge it a little bit, but in some occasions, this is why we needed to leave them longer in order for us to be able to accommodate any discrepancy that we would find here on site. And then this is a very time-consuming part of it. Once all those pieces were laid out, then we took, and I think the next slide maybe we're showing, we took all the posts. Obviously the posts are much longer than what they needed to be. All the posts had the center marked on them. If you go back, you can see that the center lines are marked on it, and the center line of each post is marked on the beams. So we could line up the center line on the bottom, line up the center line on the top, and then we had to transfer all these lines knowing what the angles are going to be. So this line, this face needed to be extended all the way up here, on the other side too, and then we needed to connect those 2 lines, and that's how we came up with this, with that angle right there. We needed to do the same thing on the top too. Very precise, very accurate measurements are needed in order for us to be able to come up with the kind of joinery that you see there. And then you can tell that we needed to transfer all those lines all the way across in order for us to be able to figure out the length of the tenons, the angle on it, and each piece was different because each piece that we carved out by hand became just a little bit different. Even though you would think that we have 2 parallel sides, they are mirror images. Even they should be mirror images from end to end, but none of them were exactly the same. So this is the mortising machine that we use. You clamp the machine onto the timber, and there is a square chisel that goes down, which has a drill bit in the center of it. So it drills the center out first, and then the chisel will cut a square mortise that we saw. And this is actually one of those pegged holes that you can only see from the outside. So when you walk up there, tomorrow I would say by the end of the day it will be open. So anytime you go up there, you should be able to see the bridge, and you lean over to the other side, and the first post on the top and the first post on the bottom and the middle posts are all pegged together so that these bays, the top, the mid, and the bottom rail, they call them bends, they all are together, and that's how we ship them from California. We were able to assemble them. This just again shows the rack. It's inside. Every piece was stickered, so we kept a tiny bit of a air gap in between them. And then we started to cut these tenons, which were several thousand cuts with the skill saw. I think we figured out on a table saw, Danny did 3,264 movements up and down, and only half of the tenons were cut at that point. But then we were eventually able to come that all these lines were cut on the line. We had a tenon sticking out, and this was just a tri-fit at the first time when we put it together, and we were very relieved that there were no gaps. And then this one just shows the process of how many cuts you need to do, because you need to cut the angle cut first down to here, and then you need to do a cross cut on both sides, and then you need to do that cut to cut this out, so you only have this little tenon left in there.
And half of it was with the handsaw and chisel.
Was it?
Yeah, once we finished on the table saw, we cut all those
Oh yeah.
off with the handsaw.
So these cuts from here to there, those needed to be done by hand. This one just shows the accumulated tenons that are almost ready to be hand planed. Each piece had to be numbered, so because each piece with no two pieces are matching at the same height or same angle, so each piece had to be numbered to a certain way, so when we look at it, I'll pick up that little piece and I know where it goes. This is a very interesting process where we didn't hand plane everything to the extent, but we do have a machine that actually, if you see down here, there are pieces of shavings that are falling out of that machine. It's mimicking the hand planing process, and we had to do it probably 8 times on each piece. Now you multiply 112 times 8. We were busy, and we got some little cuts on our fingers, a couple of accidents. And this is actually a shaving that comes off from a piece, and this shows that there was the nut there, and the machine was able to slice it so thin that the space of the nut became an empty hole. And the next slide, I think, is, oh, there should be a third one. No, just 2. Eventually we got to the point where all the bases were done. Tim actually had to ship all the bases to us to California, and then we fitted them to the posts, and then this one just shows the crate. We were able to put all 10 posts and all 10 tops and bases into this crate and secure them, and then ship it eventually. And then we got to the point where all the pieces, as you could see, they went through that machine. Some of them got hand planed because the machine wasn't able to deal with the grain direction. And then Denny spent the next 60, 70 hours putting oil on every surface. So the tenons got all the oil on it, all the 4 sides, twice. This is really the 3rd project in our existence, I believe, for the past 24 years now, that we use an oil finish on structures that are not covered with the roof. Over the course of the past 11 years since I've been working, we've been doing a lot of outdoor projects in San Diego at the San Diego Japanese Friendship Garden. And we've been seeing what happened at the Myers Sculpture Garden in Grand Rapids. And we came to the conclusion that UV is probably one of the most damaging part and radiation in this part of the country. Besides the fact that you have the 4 seasons, you have -20, you have 105 with high humidity. So this is an experiment, but I am sure that this is going to extend the life of the bridge at least 25, 30 years. So once we went through that whole process, while Danny was putting the finish on all the pieces, I was hand planing the railing, the mid rail, the top rail, and the bottom rail. We all got hand planed. This is a Japanese hand plane.
Wow.
It's a very sharp blade. It has to be sharpened quite frequently, and as you can tell, that's a 5 3/4 inch piece. I had to do 3 passes on one side in order to be able to get to the final finish.
Yeah.
It's a very thin shaving that on a molecular level cuts the cells and doesn't allow any fibers to come up when water hits it. So it becomes water repellent at that point. When you are sanding a piece of wood, you are cutting the fibers down when you are using finer and finer sandpaper, and you are trying to press it back into the wood. In this case, if you pour water on that surface now, that water would stay there and bead up on it. It will not be absorbed by the piece. Even if it does absorb it after a while, there is no grain to be raised. And this is just a very interesting shot that how the reflection on the piece actually shows the beehives in the background. So the surface becomes like a mirror image. A very sentimental value, my teacher who taught me how to use the tools and how to sharpen them and introduced me to Japanese architecture passed away a year before, and I have never used this plane that he had given me 23 years ago. And he said, when you are ready, you are ready. You will use it. And so I just felt this is the time to do it. And this is an unbelievable plane that was made a very long time ago. He bought it back in 1972, I believe, in Japan from the maker, and the maker led him into the back of the shop. This piece was not displayed. This piece was not for sale. And so he saved it for somebody who was special to him, to the maker, and he finally gave it to Duncan. Duncan held on to it for a very long time, never used it, and then gave, I think he bought 3 of these and then gave it to 3 individuals in Fairfield, Iowa, where I studied woodworking. And eventually, 25 years later, I started to use it. So this is...
How frequently do you need to sharpen the blade?
I would say probably after 2 sides, you go and sharpen. So it's basically 6 to 8 strokes on a 13-foot long, 6-inch wide piece. And you go back and you sharpen. I became very good. It actually changed quite a bit as I was doing it. I discovered certain techniques and made it faster, and it just all fell together. And then once we had the pieces, I don't know, was there an assembly? No. We had to put all these together. So the bottom rail, the posts, the mid rail, the top posts, and then the handrail were all assembled in the shop. And you can tell these are the pegs that in the center, and the 2 ends, the 2 first ones, are holding it together. We did use metal fasteners, and they use metal fasteners too. Eventually they tried not to use them, but there are certain places where you have to use them. We figured out that we thought that this joint here is going to be strong enough to hold that post there, but we couldn't put a peg in here, so we put a metal fastener from the bottom up. So if you go underneath the bottom rail, under a post, you might find a little hole, and then if you feel it with your finger, then you will see that there is definitely a metal fastener in there. we had 8 of these to assemble. This one actually is in order, so there is a certain numbering sequence that goes from 1 to 8, and then 1 to 5 on the top. These are all the pegs that had to be driven in through the material into the tenons and not coming through the other side. We didn't want to show that on the other side. We could have done pegs everywhere and it would have held it together, but I've done a bridge down, the bridge where Tim and I met in Los Angeles, and I didn't know that much about it and how it would look. But had we put pegs in each of these holes, it would have looked like that you shut it with a shotgun. So in order to maintain the aesthetics, even though it's only visible from the outside, we decided to only use 1, 2, 3, 6 pegs in each bend. And then once they were assembled, we made a large crate. We figured out exactly the size what we needed, and we used heavy packaging material, and we placed these next to each other onto the crate. The crate became 1,600 pounds. It was, what was it, 13 feet by 4 feet by 4 feet. So this one actually shows the narrow fastener that's hidden under, this is the bottom rail. Everything was assembled upside down. And then once we arrived here, this was a very easy process, taking the railing down because everything was so rotted out that we just cut through with the sawzall and removed one side for safety reasons, because we knew we would be moving back and forth. We didn't want to create anything, and obviously because we have not seen the bridge fully assembled anytime, and every time we saw the bridge it was on its side, I really wanted to make sure that the curve comes out right. So this is the base that Tim was talking about earlier, that you have the outer flange, you have the inner side, and this distance here is, so this is perpendicular to the decking, so everything is plumb to the decking, but it's 1.5 inches higher up from the bottom, so that the post material will never touch the decking. There is no wood-to-wood contact there. And then we started to assemble it. We started on the west side and figured out where the center post is, and then we went both ways so both of us could work on each side. Once we arrived here, we prescribed these ends 1/4 inch longer, as I said before, to where they needed to be. And then so when we put another post up here and we stood it up, because of all the imperfections coming from the decking not being level and all of that, we ended up rescribing each of them. And we can do, well, Danny is faster than I am now, but these 2 joints are touching the post. This one is cut further back to a certain distance, it's usually 3 inches. And we can do 1, 2 scribes per post per day. So we figured out that it would take us 16 days to be able to do the 8 bends. And then so this is how it starts. Once the post is set up, we figure out how it's the most plumb, and then there are always these little gaps here. So we have a little scribe with a pencil, and then we'll run it by the edge of the post. We can't really use a metal scribe because then you would scratch the post. And then there will be lines showing here, maybe 1/8 of an inch, sometimes it's 1/4 of an inch, and then we grind those with a handheld power tool, which has a nice grinding wheel to it. And once those are ground out, we can actually really match it to the line, to the pencil line, and then Danny actually came up with a really nice 8.5 or 9 inch PVC pipe, and we attached a piece of sandpaper to it, and then we are sanding it all the way down until it matches the curvature of the post. We use a little chisel too at the very end of it. We cheat quite a bit. Because
We'll never know.
you would never know, you would never see it because the joinery is so tight on the top and the bottom, but the middle one is all hollowed out. For two reasons. Just in case there is any water that gets in there, it will get out too.
Right.
And so that's why caulk is our main enemy. Because once you caulk that area, you trap moisture inside there because the caulk will eventually peel up, let moisture to go in there, but it will not be able to dry out as fast as in this case. And the joinery came out, I mean, I'm really glad that Danny is so proficient after such a short amount of time that I can just let him do it. And so this one actually shows an almost completed one. This is actually a shadow line, so that piece actually continues and touches the post, but there is just a little bit more here that needs to be scrapped to it. And if you go out there and then you can look at all those joints, I would say 90% of them are really, really, not even an ant or any other small animal can get in there. So this is how it turns out to be to the very end, where it's very tight. We do have a method and a mechanical fastener between the post and the railing. Again, if you look under or if you feel under each mid and top rail, from the bottom of it, there is a little channel and there is a little square hole. So we drill, if you go forward, I think, one more. Yes, so the metal fastener has a wooden thread on one end and a machine thread on this end. So when the top rail slides over it, it penetrates through the middle of that beam, and from underneath we put a washer up onto the machine and machine thread end, and then we'll, with 2 fingers and just with feel, we'll try to put a knot on it. Sometimes it takes a half an hour, sometimes it takes 5 minutes. And then we tighten everything together so that there is a mechanical fastener between the post and the railing, and that pulls it all together. The other important fact that you probably need to know about is that in between all the members, the feet and the decking, we use a sheet of copper. And we use that because that will prevent any kind of fungus growth, which probably will decay the material a lot faster. We try to keep the the construction as simple as it can be, so it can be taken apart, repaired, and then put back. And in this case, the most vulnerable pieces are probably the bottom pieces, because that's where the dirt will accumulate, that's where ants, that's where spiders will come to, and having a piece of copper there will prevent any kind of decaying process happening. It's a very thin sheet of copper sheet. You might see it in a couple of places if you really look for it. But other than that, this is where we are. I think this was a couple of days ago. We are done with this side. This is the west side now, with a panoramic view. We just completed the east side, and we only need one more post to be scribed. And then so we are hoping that within 6-7 hours by tomorrow, we can open it up to the public by the time the concert starts. That would be the goal. We had to order, obviously, we had 6 Giboshi, these finials that are cast bronze finials. Luckily, they are still manufactured in Japan. We were able to order it, and if you look very close, there are 2 little details that will tell you which one is the old one and which is the new one. But I let you figure that out.
So will it remain the natural color?
For the wood or for the Giboshi?
For the rails?
The railing, this is not exactly the natural color of it. The natural color
But this
is
is what
much
will stay.
lighter, but this is what will stay for some time. This is what we use is a Livos product, Livos. It's a German manufactured product. Very good, I've been using it for over 20 years now. Not exterior, but interior pieces. I really like it, it's a very easy application. It's healthy, so not that you can drink it, but to the point where you basically just wash your hands and then everything goes away. It doesn't, we could have done the whole finishing process inside without any ventilation.
Is that the oil you put in?
It is the oil that we apply to all the pieces after we hand planed everything, and it did take on quite a bit. I mean, we used up 5 liters, so we probably used up, what was that? 1.5 gallon to 3.5 gallons of oil on this project, and there's a little can left. So hopefully this will stay the color for some time, and eventually it will start darkening. It will become maybe a little brown color like that in a year or so, and in a couple of years it will gray just like everything else will naturally age. The oil will need to be applied between 2 to 5 years. I assume it might need to happen a little bit earlier, but it's a very easy process because you just put it on, wipe it on, wait 10 minutes, and then wipe it off. So maintenance wise, this will require a lot more maintenance than the painted bridge did before, but because we are not penetrating into the posts, there is no cuts on the post to receive the top rail, mid rail, or bottom rail. We are eliminating all of that fact that where a piece can actually start rotting. Unfortunately, I mean, the beauty of this bridge is the curve. But as the handrail curves, the water is always going to run down into the post. So had we cut into the post, you disturb that fiber and you allow the fiber to decay a lot faster if you have any joinery in there. So it's traditionally, I believe it's trying to be true to the Japanese architecture and to the Japanese joinery, and we used it as many times as we could, but we invented a couple of steps just because we learned from the previous process. And looking at the Cypress bridges, what it's called, the other bridge that's curved by the waterfall, yeah, how that bridge is decaying too, to the point where it's gonna need replacement or restoration. So trying to learn from it and trying to invent a different approach to it, but at the same time trying to stay with the joinery, the hand planing process, and making sure that this material that is very valuable may not be available for the next 150 years, but I really would like to keep this piece here for at least 75 years. So that would be 3 times more the lifetime of the previous one. So we just have to see. Yes?
What about the walkway part?
The deck.
Does that have to,
Deck.
does that have to be eventually?
No. The decking is gonna outlive or my great. Yeah, that Ipe is from South America. It's very strong material, and it's 4 inches thick.
eBay?
It's called IPA, which is Ipe. Yeah. Usually you can find it in 1x6. The 4x6 took a little bit of time to find, but it became available. No, that decking material is bulletproof.
What year was the decking?
2014,
Thank you, sir.
when you replaced it, yeah. And for that, I think they needed to remove all the railing from it, and at that point, the bottom rail was replaced. So the bottom rail was a new pieces, but everything was laminated on the old bridge. So they used 1x6 material, and they glued them together to a certain radius, and that's what they used. In our case, it's every single piece is solid wood, so no lamination was done.
So this is your most labor-intensive bridge you ever built in your long career?
In my short career, yes. It is. We have done several other bridges. I don't know how it all happened, but San Diego has 1, 2, 3 bridges that we built there. None of them are as big as this one, obviously. Actually 4. No, 1, 2, 3. Yeah, 4 bridges that we built there.
So how long did you work on it in California?
We started back in January, and we finished tomorrow. Oh, back in California, that was 2 weeks ago when we arrived. And I only took 2 weeks off, and I worked 6 days a week.
So about 5 months?
Easily. I don't know the hours. I lost track of the hours.
Labor a lot, huh?
It's definitely a labor intensive. There were several factors that everything just fell into the right place at the right time. And obviously we have gone over the budget, but we are not charging the Anderson Garden. Oh, Tim didn't hear that.
What did I miss?
For several reasons, because the price was given to the garden prior to the pandemic. So before I priced the shipping was 75 cents a mile.
Wow.
No, the shipping was 125 cents a mile. So it all kept creeping up a little bit on us, and everything got a lot more expensive. Luckily, we purchased the material ahead of time, ahead of the pandemic, and because then it almost doubled. So.
I'm curious, what do you do in your spare time? I mean, what actually do you do? You don't just build bridges, do you?
This is a full-time job.
Building bridges?
Building. I started to advertise myself as a Japanese carpenter,
Okay.
and then everybody else said, "Oh, we do the same thing, done in our region." So I changed it, and now we are running an architectural millwork shop. So you can bring me timber that's 18 feet long, and I can cut chopsticks out of it.
Oh, okay.
But we basically manufacture and restore structures in Japanese gardens, private or public gardens, within the country. So the extent of travel is up to Grand Rapids at this point. We work at the Chicago Botanic Garden. We work at the Osaka Garden, down south side of Chicago.
Yes.
It's
Oh,
a very
yes.
small garden right across from the Obama Library. The Anderson Gardens here. We did a bridge. I hand planed the bridge for Dallas, Fort Worth, and we are preparing to go to Portland, to the Portland Japanese Garden.
Right.
They asked us to do some
Good
work
luck.
there too. So yeah, high standards. So that's what we do. What do you do for hobby?
Dávid and I met in 2017, but prior to that, I've done a lot of manual labor and a lot of art. I've worked with my hands my whole life. My dad is a Western carpenter. My great grandpa was a traditional Japanese carpenter.
In Japan. Yep.
Um,
He's got the good blood.
Yeah, any meticulous work I love doing.
And he's very good at it. But on the side,
Oh, right. My partner and I have a flower farm.
Oh.
Yeah, before I met David, I was full-time farming.
flowers, not vegetables, flowers, native flowers. And in my case, I mean, I obviously try to spend as much time with my family as possible. I have an 8-year-old daughter and a wife at home, very eager to have me back. And I keep bees. So I keep bees, I collect swarms, I take out large established hives from structures, even though it's getting less and less popular because it can be a very extensive, very long hours and very labor intensive. But we've done several large hives removing from buildings. So that's where our life is. And there are several samples here of certain kind of joinery. We can go through it probably quickly. I'm not going to lift the rock up, but this is basically how a foundation for the Ojai and the gazebo was constructed, or should have been constructed from the beginning, but that's how we repaired it. So all the posts are elevated above the finished floor, which would be in this case the finished grade. And then we place a rock on top of that foundation, and then we carve the bottom of the post so it fits the contour of the top of the post, top of the rock. And it fits beautifully there. In our case, we go through with a threaded rod, going through the rock into the post, and from the side we use a washer and a nut to tie it all together. And there are different joinery techniques here. Some of them are so tight, some of them might. I think this one will come together, will come apart. It's called the gooseneck joint. Very interestingly, all the pieces are, by the time you hammer it all together, they are really, really tight. Most of these joints are usually used when you don't have a long enough beam. Then this is a joint that you use. So when it's all put together, there is usually a post coming down here, and you don't see any lines. You only see that part. The top part, which is the most interesting part, is all hidden. There's another joint here. This is a scarf joint, which is basically exactly the same piece that was cut out from one piece. And again, if you don't have a long enough beam, then you switch them end to end. You align the points where they go into each other on both sides, and then you end up tapping a little peg in there that's tapered, and it pushes the ends together, and that's what you will see. It's very time consuming, but it's very, very strong. There's a very interesting joint here where you have a post and four, or actually in this case, 4 members are coming into it. The pieces are joined. Is this the one? So this is inside there, and you put these 2 little keys in here, and that's what holds the pieces together inside the post. But this way you can match. You have another piece here with the same cutout. And so B square. So that goes through there, and then it goes through there. You put the key in there, and it's all locked together.
What is the key made of?
The key is usually made out of some hardwood. In this case, most of the timbers are lightweight, soft material. This is made out of Porterford cedar, which is a very fragrant material, very good exterior grade material. But in Japan, this is what they call the hinoki, and most of their houses are built out of that. So when you walk into a house, you can smell you should be able to pass it all through and then just.
So do they
That's
use
not
this
as fragrant.
joinery in building their homes?
Oh yes,
Yeah.
yeah, it's extensively used everywhere.
There are likely variations on these joints throughout the guest house, the tea house.
Yes, so it's not really visible at all to the naked eye. You would need to go up there, or it's behind the plaster or everywhere. But all these joints are used in the guest house and in the tea house too.
David, those pins that you were using to put things together appeared to be a different material.
Yes,
What?
that's kayu batu. It's from Indonesia. It's a very hard material. We use it for decking, and we just happen to have some extra, and we cut that out.
And are those then epoxied into place?
No,
They're just sitting there.
well.
We didn't talk about offsetting the 15 millimeter.
Yeah, so when you have let's say this was one of the posts, this was the top rail. When you put this, I don't know if this goes from this side or from the other side. So it should go from that side.
Yeah.
So when you mark the two pinholes, you mark this pinhole a little bit lower. So when the pin goes, when this is all put together,
It draws it
then
together.
yes, I can't put it together, this is so tight. The pinhole over here, it's actually lower, 2 millimeters, 1.5 millimeter, 2 millimeters lower. So as the pin goes in, it hits the top of this here and then draws it up. So it even pulls
Is
it.
that a tapered pin?
No,
It's a square pin?
it's a square pin with we put a little chamfer on the beginning so it can actually
Okay.
go under
Yeah.
this.
Yeah.
But as the rest of the material goes up, it forces it to put it together
Wow.
even harder. You need to loosen these up in order to really make that happen. This is something that is displayed in the tea house, where there is a lot of round timber. And this is basically a natural round timber that they took the bark off. There is a special place where they grow timbers like that. Every year, from saplings, as they grow, they start cutting the first couple of side branches off. So that's what would create these nuts. And in many cases, if you cut these down at a very early stage of the tree, then the bark will overgrow those nuts basically, and you will never see them. So when you go into the tea house and then you see the Tokonoma area, there is a post that's called the Tokobashira, I believe. And that post has no nuts in it because it was grown at a certain place for that purpose, that wood is going to be used in a Tokonoma as a main post. And then people go in and they cut these little first couple of branches off, and then you have a beautiful surface.
Yeah.
Obviously, this is just a sample piece, but this is another obvious place where, how do you join these together? You mark the center of each piece, you all put it together, and this goes this way. You scribe one piece to the next. So by the time it all fits together, it's a beautiful joint.
Yeah.
It is time consuming. It is definitely time consuming, but it creates a beautiful joint that you can either put a wedge in here on the top, or you can put a metal fastener in there, or you can peg it from the sides too. It's just round timbers like this introduce a totally new concept of how do you do the layout. There's a lot of guesswork, and you have to have your plumb line and level line tattooed into your eye in order for you to really figure out where the joinery is going to be.
What is that joinery called?
It's a mortise and tenon.
Mortison?
Mortise and tenon.
Which part is the mortise?
The mortise part is the female part, and the tenon is the male part.
May I ask, how did you get interested in joinery?
I came to the United States from Hungary 30-some years ago, and I studied English. I wanted to extend my stay here in the States, and the only way was to get involved with the university where I was studying. And they offered a work-study program where we worked for 5 days for the university building cabinetry, and then we studied 1 day. And after the first year of going through sheet goods and making basically small objects out of plywood, we forced our teacher to teach us something a little bit more interesting. So he got us into mortise and tenon joinery, not with the Japanese tools, but there was somebody in town, Duncan MacMaster in Fairfield, Iowa, who was already using the Japanese tools. And we had a chance of buying 10 chisels for $10 from Harbor Freight, or 10 chisels for $350 from Duncan. And he actually loaned us a couple of chisels, and then once he showed us how to sharpen them, it became obvious that these tools are special. Because these tools are all handmade in Japan. There is no manufacturing process where you are mass producing it through, selling it through Amazon. It's a very old traditional way of the original people who were making tools were making actually swords for the shoguns. And because the whole culture collapsed and they really didn't need more weapons, then the woodworkers became more interested in having these people make the tools for them. The tools are special. There is a certain process that goes into it. It's usually handed down from generations to generations, and you need to learn it for several years. I mean, in carpentry, they usually start teaching around age 10, 12, and then for the next 15 years, you are a laborer, and then you become a fully trained carpenter in 15 years. So I've never been to Japan. I've never spent, Danny has spent more time there than I did, and obviously he has, family still living there, but he has a lot more connection over there. I was already 23 when I met Duncan, and at that point he called in to his associates in Japan and then wanted to send us out there, and they said, no, you're too old, too much ego. A 10-year-old doesn't have an ego, or doesn't know it has an ego.
No.
But obviously they don't want to train somebody who has some kind of a background. But I was lucky enough to be able to work with timber framers, first with Western timber framers, and then with large Japanese constructions within the United States, and traveling, taking 2-3 week long workshops with Japanese carpenters who would come from Japan. And eventually one of those jobs landed another job in Woodside, where there is a 25-acre Japanese compound with authentic Japanese structures, beautiful landscaping throughout the whole 25 acres. It has a 2.5-acre man-made pond. It was built for the CEO of Oracle. And I was hired to do a certain part in 1998 for 3 weeks, and then I was illegal, so obviously they couldn't hire me. But I came back in 2001, and I worked there until 2004 on certain parts of that project. I mean, that is a 12 or 13-year-old project that was going on with 50 carpenters on site and another 35 carpenters in a shop. Altogether, we had years where we had 350 people working every single day on a job site. But that's probably one of the most authentic Japanese large compound outside of Japan. Besides, obviously, the Anderson Garden, the Portland Japanese Garden, there are public places. This is still owned by one individual. So that's my background to it, and I know 1%.
Really?
We are very lucky to have the Anderson Gardens and Tim and John to be able to support us and ask us to do and push our limits to learn more and more.
Well, thank you, Dávid.